Okay, so we've finished looking at the approximation methods for integration. What we're looking at now is called the fundamental theorem of calculus. And that is that the area enclosed by any curve, so y equals f of x, the x-axis, and the line x equals a to x equals b, so just from the two different values of x, is given by the primitive function. Okay? And then we substitute in from f of b and we subtract f of a. So this is what we were talking about in that very first lesson, and it's called the fundamental theorem. Now, if you need a refresher or if there's anything that you don't understand, then go back and have a look on YouTube. Eddie Wu has got a very detailed explanation if you want to go back over it again. But once we know this, then as long as we know what the function is, we can exactly work out the area. So what does this mean practically? Because we've talked about the theory behind it. Now we're actually going to look at the nuts and bolts of how we do this. All right, so if we are asked to find the area below the curve y is equal to 2x from point x is equal to 0 to x is equal to 2, what we get is this integral that you see here, is this first example. Okay, and the way you do it is you find your primitive function. So the primitive function of 2x, is x squared, and that's going to be from, now this is the setting out you need to use, okay, from 0 to 2. Okay, so you have to show that step. Your next step is to then say, well, I substitute in the 2 and I get 2 squared, and then I subtract and you substitute in the 0 and you get the 0 squared. So this is equal to 4. Okay, which if you think about it geometrically makes perfect sense, because y is equal to 2x is this straight line, and if we're going from x is equal to 0 to x is equal to 2, we have that, and so this side here is 2, oops, this side here is 2 because it's going from 0 to 2, and the height of 2x, 2 times 2 is going to be 4, and we've got a triangle, so the area is a half times the base times the height, which is 4. Okay? So what about if we make it a bit more complicated then? Okay, we want to know, well, what is the area below this line 2x minus 3 from the point x equals 2 to x equals 4? Alright, so well, what is the primitive function of 2x minus 3? Well, primitive of 2x is x squared, minus the primitive of 3 is 3x, and we are going from 2 to 4. Okay, then we're going to substitute in, so we get 4 squared minus 3 times 4, and then we subtract, now you substitute in your 2, so 2 squared minus 3 times 2, and we end up with 6. Now again, you can go and you can draw the picture and you can verify that. You end up with trapezium in this case, and the area is equal to 6. Now so far they're straight lines and you're thinking, well, what's the big deal, I can just work it out, right? But what if they're given us a function that's not a straight line? For instance, x squared. So we want to know the area below x squared from x equals 0 to x equals 1. It's no longer a straight line. We don't get a quadrilateral. We don't have a formula for that, so we have to integrate it. So what we do is we say, well, the integral of x cubed, of x squared is x cubed over 3. And we are going from 0 to 1. So do your substitution, and we end up with a third minus 0, so it's a third. Now if they were asking us what the area is, you would then say 1/3 unit squared. Alright? I would like you to have a go at number 4, so pause the recording, have a go, and then come back and see what I do. Alright, so when we integrate this, so x cubed, we get x to the 4th, and it's all over 4. And then 8 is going to be 8x, and we're going from -2 to 2. Okay, so you go through and you do your substitutions. So you should end up with 2 to the power of 4 over 4 is 4. And then 8 times 4 is 16. And then we are subtracting. And now if you put negative 2 in there, hey, you end up with 4 again, but now we get minus 16. So that's going to be 32. Okay, again, have a go on your own. Pause the recording, have a go, and then come back. X cubed. So the primitive of x cubed is x to the power of 4 all over 4. We are going from 2 to negative 2. You get 4 minus 4, which is equal to 0. Alright? So when you have a product, my advice, expand it. Because once it's expanded, it's a very easy process to integrate. Just add 1 to the power and put it over the power. If you don't expand it, you are going to screw it up. That simple. So expand it first. So when you expand this one, you get x squared minus 10x plus 24. Oops. And we are going from 0 to 3. Okay. Now we can integrate that easily. We're just going to add 1 to the power, put it over the power, add 1 to the power, put it over the power. Hey, I can simplify that to 5, can't I? Don't have to, but might as well. We can do that. So from 0 to 3. So when we substitute into that, you put in your 3, you're going to end up with 3 cubed over 3 is 9, minus 45 plus 72. And then, well, 0 is pretty easy, isn't it? So we end up with 36. So even though it looks complicated, once you expand it out, it's easy. Alright, what do you think you might do on number 7? So if we've got a product we want to expand, if we've got a division, what do you think you might do? I'm going to divide it. So I would like you to have a go at cancelling it down and then come back and watch how we do it. So when I start cancelling out, so 3x to the power of 4 over x squared is just 3x squared. And minus 2x squared over x squared is just minus 2. So cancelling out makes this one very simple. Okay, so we end up with x cubed minus 2x going, whoops, sorry, going from 1 to 2. And so when you substitute in, you end up with an answer of 5. So what do you do for one that's written like this? The integral from 1 to 2 of 1 over x to the 4 dx. Well, remember, if we're differentiating, I can differentiate anything with a power. It's the same deal here. I can integrate anything with a power. So write it at a negative index. So the integral from 1 to 2 of x to the negative 4 dx. Now, this is something you need to be careful of, because the biggest mistake that kids make is say, well, minus 4 plus 1 is minus 5. Is minus 4 plus 1 minus 5? No, it is not. Please do not fall into that trap. Minus 4 plus 1 is minus 3. Alright, put it over the power. So then you've got to put your negative 3. And it's from 1 to 2. So when you do your substitutions, you can rewrite this first. If you don't like it like that, that's fine. We can put it like that. It's a nicer way to deal with it. You substitute in, you're going to end up with some fractions. So we've got minus 1 over, so 2 cubed times negative 3, so that's going to be 24. Minus, and then if I put the 1 in, I end up with minus a third. So my final answer for that one is going to be 7 over 24. Alright, so there are all the techniques you need to be able to do exercise 3.3. Have a go at the even questions, and if you're struggling, have a go at the odd ones as well. Good luck, we'll see you in class.